Between 1900 and 2008, the global ocean warmed by about 0.6 degrees Celsius, but the western boundary currents, the Gulf Stream Corrosional, the Brazil Agahars, and the eastern Australian currents warmed by 1.0 to 1.4 degrees Celsius. This is attributed to a poleward shift in the mid-latitude extensions of these currents. The role of winds is unclear. As the southern hemisphere, the westerlies strengthened, but not in the northern hemisphere. Nevertheless, these warmer currents will affect the ocean atmosphere heat transfers and the development of cyclones. During the last 3 to 4 decades, the frequency of El Niño events has increased while La Niña events decreased. This has been attributed by some scientists to global warming, but the case is not yet established. In the last 3 decades, there has been an expansion of the tropics in the northern hemisphere. Various metrics show an average expansion between 1979 and 2009 of 0.33 degrees per decade. Allen et al. Attribute this shift to the heating effects of black carbon aerosol and tropospheric ozone, especially in the warm season. The relative frequency of cold spells has decreased, and the frequency of hot days has increased over most land areas in the late 20th century. In Europe, the frequency of hot days has tripled since 1880. In the United States, there has been an increase of about 12 days in extreme 85th percentile apparent temperatures in the 60 years since 1949. In Colorado alpine zone, the area classified as tundra according to Köppen classification shrank by 73% between 1901 to 1930 and 1987 to 2006 as a result of summer warming. According to Desi and Azasheld, drought areas have increased, especially in the tropics and subtropics. There has been widespread drying over Africa, East and South Asia, East Australia, South Europe, Alaska, and northern Canada from 1950 to 2008. Most of this drying is due to recent warming. Since the 1970s, the area characterized as very dry by the Palmer Drought Severity Index has more than doubled. At the same time, it has become wetter in the United States and most of Western Australia. The global percentage of dry areas has increased by about 1.7% of global land area per decade from 1950 to 2008. Nevertheless, the frequency of heavy precipitation events has also increased in most land areas. This is mainly observed in regions and seasons where there is strong moisture transport from the ocean to the land rather than summer, when there is interplay between soil moisture and convection increases in the frequency and intensity in North Atlantic hurricanes have also been attributed to global warming, but the case for this is still being debated. So Gordon Valentine Manley was an English climatologist who has been described as probably the best known, most prolific, and most expert on the climate of Britain of his generation. He assembled the Central England Temperature (CET) series of monthly mean temperature, sketching back to 1659, which is the longest standardized instrumental record available for anywhere in the world. It provides a benchmark for proxy records of climatic change for the period covered and is a notable example of his scientific scholarship and perseverance. It took over 30 years to complete. His 2 papers describing the work are available online. Research work: mutual investigation of Arctic haze in the 1950s found aerosol particles which apparently originated from industrial areas from Europe and China. Using studies of nuclear fallout from bomb tests which showed how aerosols moved in the upper atmosphere, he compared global temperature statistics with the record of volcanic eruptions in a 1961 paper, which put forward his view that large eruptions had significantly affected temperatures at a hemispherical scale. Average temperatures had fallen since 1940 despite a lack of eruptions, and he thought this is an angina which might indicate a long-term rhythm on cycle. In a seminal 1963 paper, he analyzed data from nearly 200 weather stations to show increasing temperatures from the start of this data in 1880 up to about 1940, followed by multi-decadal cooling. He continued his statistical investigations, and in 1969 paper calculated that about two-thirds of northern hemisphere cooling since 1940 had been caused by a few recent volcanic eruptions, leading him to conclude that man has been playing a very poor second fiddle to nature as a dust factory, though he thought that human influence could increase. In a 1971 paper, he calculated that human aerosol emission might result in global cooling after 2000, but depending on circumstances, these emissions might cause a warming effect, indicating that human had been an innocent bystander in the recent cooling. Calculations were too basic at this time to be trusted to give reliable results. As research developed, he drew attention to increasing evidence that warming climate, particularly in polar regions, was due to human-caused greenhouse gas emissions and could change weather patterns to determine a detriment of agriculture. Hermann Voll was born in Frankfurt, and he published extensively on tropical climate, the Asian monsoon, and teleconnection patterns. Well, teleconnection patterns. We have to remember Hermann Voll. In 1941, he wrote the first paper in German on human influence on climate. He was head of meteorology department at the University of Bonn in Germany. He wrote a number of books in German and English, including one on the climate of Europe. Let's summarize this. We spent a lot of videos a lot of time, kind of like 9 videos, talk about Cenozoic, Quaternary, Pleistocene, Anthropogenic, and climate change. There have been several major ice ages in Earth history. Snowball Earth conditions occurred twice in late Proterozoic time. Since 500 Ma, there were glaciations in the Ordovicial, Carboniferous, and late Cenozoic, and a major ice-free climate in the Cretaceous, associated with high carbon dioxide levels in the atmosphere. A major driver of climate change on the glacial time scale has been plate tectonics and an associated continental drift, mountain building, and volcanic activity. In the early Cenozoic, around 65 to 50 Ma, global climate was born, but then a cooling trend began that led to ice buildup in East Antarctica around 33 Ma. The continents were in their present positions by 17 to 15 Ma. Perennial sea ice formed in the Arctic about 14 Ma, but there was no major land ice cover in the northern hemisphere until around 3 Ma. The Quaternary period that began at 2.6 Ma witnessed numerous glacial cycles that are identified in the marine isotopic record of oxygen-18 until 800,000 years ago. There was a dominant obliquity signature of 41,000 years that then switched to 100,000 years. Although the orbital eccentricity effect on solar radiation is minor, for recent glacial cycles, glacial conditions took up 90% of the time. The last interglacial, the Andaman, peaked around 125K with temperature higher than in the 20th century. Cooling began around 115K, and there was a full glacial. By 75, conditions moderated, and then the last glacial maximum occurred around 21K. Global temperatures fell about 6 degrees Celsius, and sea level dropped 130 meters. The glacial cycle was marked by rapid 1,500-year climate fluctuation known as Dense-Goddard oscillation, related to changes in North Atlantic circulation. The younger Danger's Cold event was attributed to massive influx of fresh water into the North Atlantic from glacial Lake Agassiz. The African cold arid phase marked the glacial conditions. And the post-glacial Holocene began in 17.1K was less variable than the Paleocene. A further orbital factor affecting climate is the precession of the equinox. Currently, perihelion is in January, but in 10,000 years ago, it was in July, making northern summers hotter and wetter. Savannah covered the Sahara from 1950 to 6,500 BP. In Holocene, thermal maximum was from 8,000 to 5,500 BP around AD 950 to 12 to 50. There was a medieval warm period in Europe and the North Atlantic, followed by the Little Ice Age in the Northern Hemisphere, with glacial advances in Europe peaking in the mid to late 19th century. Volcanic eruptions in the late 13th century may have triggered the Little Ice Age. The Anthropocene, marked by pronounced human effect on global climate, is dated to about 1800 AD, the start of the Industrial Revolution. Greenhouse gas effects were first noted in 1896. Water vapor accounts for about half of the greenhouse effect. Carbon dioxide measurements began in 1957, with earlier data obtained from ice cores. Since 1800, carbon dioxide levels have increased by 40% from 280 to 391 ppm, and methane rose 2.5 times. The total radiative forcing is about 1.6 watts per square meters. Anthropogenic atmospheric aerosols led to a global dimming over the 1950s to 1980s, but this has now reversed except for India and China. Mean global temperature rose by 0.7 degrees Celsius. In the 20th century, in the Arctic, the warming was twice as great, partly as a result of ice albedo feedbacks, and in the 2000s, Arctic sea ice shrank dramatically in September almost worldwide. Glaciers have retreated greatly since the mid-20th century. The frequency of hot days and heat waves has increased. Also, the frequency of heavy precipitation increased in most land areas.